Hey everybody, this is Dr. Duncan with the second video summarizing the study by Dowdy and Connor, nonchalant flight in tiger moths is correlated with unpalatability. In this video, we'll cover the methods of the paper. Not all the methods, just the important parts that influence the outcomes of the study. I want to point out that this method section starts off with an ethics statement about how bats were not harmed in the process of the study. They were basically fed moths. Ironically, this says nothing about the ethics of feeding poor little moths to bats, so I'll leave it to you to ponder the ethics of that. All right, so the moths were collected at a black light at night on a sheet, much as you see here. Dr. Van Zandt does work like this. If this looks like a fun way to spend your evening, and I promise you that it is because I've joined him many times, talk to Dr. Van Zandt. Now, the moths that were collected were 5 species of tiger moths. These are the pictures of those 5 species that were used in this study. Some of them are very cryptic in their coloration. Some have very gaudy coloration. My favorite for sure is at the lower right. That hot little package is Cisthene martini, which not only is bold and beautiful, but has one of the best scientific names to pronounce ever. I'll say it again, Cisthene martini. Now, pretty early on in the methods, something of a mystery arises. You might have noticed that the authors make a big deal out of the fact that for some of the moths used in the arena trials, they removed the moth's tymbal, which is the sound-producing organ from the moths. And they also had untreated moths and some moths that they had a sham operation on that left intact the tymbals. So those moths that were in the sham treatment were able to make noise. They explicitly say that all 3 treatments were used in the arena trials when they were feeding the moths to free-flying bats. They only used the silenced moths in the palatability trials. But interestingly, these mentions in the methods are the last mentions of this treatment in the paper. Nowhere in the results or the discussion or supplemental information do they show whether this treatment impacted capture trials. I suspect that this was part of another study that they were conducting at the same time that was testing a different hypothesis, perhaps one where they examined the effect of the moth's acoustics on the bat capture. Recall earlier in the introduction section I talked about how these tiger moths produce sounds when they're approached by bats, and so they were probably trying to figure out more about what's going on there. So it's just fine that they were working on 2 different hypotheses at the same time and that those hypotheses are explained in different papers, but they really should have explained this to the readers of this paper so that we understood the impact, if any, of this manipulation of the moths. I suspect that it had no impact on the trials, which is why they left it out of the results in the discussion. So I'm willing to give them the benefit of the doubt, even though the authors and the editors should have caught this and made sure that something was said about this to keep the readers to understand what was going on. Okay, some of the highlights from the study. First, let's turn to the outdoor flight arena. This was basically a large field where they had 2 ultraviolet lights suspended off the ground. The lights attracted lots of insects. This was, of course, done in July and August when you have the peak flight season for moths and other night-flying insects in southeastern Arizona. Because of the attraction of the insects to the lights, it also attracted bats. This is something that's known. This was something that's well known, that bats will congregate around lights that attract moths and things like that. So nothing new there. The moths that were included in this study in the feeding trials to bats, they were released one at a time, starting at about an hour or so after sunset until they ran out of moths, basically. And part of what allowed these researchers to be able to see what happened with the interactions between the bats and the moths, it was done using high-speed infrared cameras and ultrasound-sensitive microphones. What is an ultrasound-sensitive microphone? Well, bats and the moths, the sounds that they make are pretty much inaudible to the human ear. And so we have to use electronic devices that capture those sound signals and then turn them into audible signals that we can hear. And that's what meant by that technology. Now, the authors acknowledge that there's issues of what's called pseudo-replication here. Pseudo-replication is when you are sampling the same subject multiple times. And so, for example, on any given night at the flight arena, it's probably some of the same bats that you're feeding different moths that you're releasing. And so there's the possibility that individual differences in behavior or tastes or capturability, etc., or tolerance to toxins amongst individual bats could be influencing the outcomes. So they acknowledge that, and they do explain that they were doing this over the span of 3 years, which increases the chance that they were sampling unique bats. However, one thing that they don't talk about in terms of pseudo-replication was the palatability trials, which we'll talk about in a few minutes. They have no mention there of how many bats were involved in the palatability trials. The authors go on to tell us about how they used the data that they collected from the arena trials. They had almost 350 bat-moth interactions across those 5 species of tiger moths. And they acknowledge here that they included both the moths that could make sounds as well as the silenced moths in the study. And we've already talked about that. Importantly, down to this bottom section that's highlighted, they explained that they classified the moths into 2 categories, and this is across all 5 species of moths. They either categorized them as moths that exhibited dives, which is where the moths essentially fold their wings and go into a nosedive to get out of the anticipated flight zone of the bat. And this behavior was labeled evasion, or moths were labeled as being no evasion. In other words, they showed no clear attempt by the moth to get away from the bat. They did have very few cases, about 1 in 9, where the moths would sort of turn away slightly and fly at a different angle, but those were rare, and I believe that they included those as no evasion moths. All right, what I want to do next is show you the supplemental information on about the trials. They included this in the supplemental information, which you can find on the website at the journal that published the article. So let me get that set up. Okay, this first video shows example of nonchalant flight by the moth. The bat is highlighted in the red circle at the top right. The moth is in the blue circle at the center of the video. You also see the researcher at the bottom center with a headlamp on, and the researcher is holding some device that I believe is that ultrasonic sound detection system. So let's play the video and see what happens. What you're seeing is the moth is holding its ground, and the bat comes in close, takes a look at the moth, or takes a listen to the moth, and then flies away. So that would be an example of the nonchalant flight of the moth. It was clearly not interested in diving and evading the bat. Let me set up the next video. Okay, this will be a video of an evasive dive by one of the moth species. So let's see what happens. It should be the same setup as before. Here comes the bat from the top left. There's the moth. Keep your eye on the moth. Boom. You see how the moth drops? Nosedive, got out of the flight path of the bat. Okay. The bars, interesting, the bars that you see here, this is probably where the researchers are digitally analyzing the video to take their measurements. And I noticed that bar appeared like where the moth was before the dive, and then where it was last seen when it pulled out of the dive. And they might be doing something like measuring how far it is that the moths are diving. We don't know. That would be part of a different aspect of the study they don't mention in this paper. One of the reasons I'm showing you guys these videos is not just because they're cool and they tell us a lot about like how the study was done, but also to remind you to look for supplemental information. It can be really instructive for understanding studies. Okay, let's next turn to the trials to determine how palatable the moths were. In short, they had captive big brown bats. That's the common name of the bat, not just like, oh, they were big and brown. That's the actual name. And they fed a variety of moths to the bats, including species that were not part of the study that were known to be palatable. And then they also would slip into as they would sequentially feed moths to these bats, they would slip into the diet or the feeding trial are 5 species of tiger moths. And basically they explained the sequence that they did this and how they decided to stop feeding, at what point they decided to stop feeding moths to bats, because of course once you stuff a bat full of moths, no matter how delectable that next moth might be, that bat's going to say, no thank you, I've had my fill. So basically, this is how they were able to determine the palatability of the moths or unpalatability of the moths by observing the behaviors of the bats in captivity. Okay, that concludes the review of the essential methodology for the paper. The next video will be on the results and discussion.